everyone. This video is about directivity. Um, to go over to start with, let's revise what we have learned. And in the previous lectures, we have learned average intensity. Average intensity is also the intensity of an isotropic antenna. We have also learned that the normalized power can be calculated by dividing the power with the maximum value. And we also learned that from the first chapter, according to Ponting theorems, if S is the power density, S times the area will give you the power. So according to this equation, the so-called normalized power is S times A divided by S maximum times A. By the way, this is just a ratio. And in this case, the area on the top of the expression and the bottom of the expression is the same. We can cancel out with each other. And by the same token, we can also substitute A with some other number, say R squared, R squared. And in the previous chapter, we have learned that the power density times R squared is the intensity, because intensity is the power per unit solid angle. So based on what we have learned, we are going to continue here with, with some important information. Directivity. The first thing that we need to know is the definition of directivity. According to IEEE, directivity is just a ratio of radiation intensity to the radiation intensity or to the average radiation intensity over all directions. So according to IEEE, radiation intensity, the directivity is given by a ratio of what intensity in a given direction. And then the intensity, the average intensity over all directions. Over all directions. So this is the definition given by IEEE. So based on what is given here, right? Given direction, the directivity is different from different direction. So we better use the angle to represent this formula. And the intensity in a given direction will be U times, and the average intensity all over all directions is the same as average intensity, right? The same as the intensity for the isotropic antenna. So in this case, U naught there is no direction for the bottom expression because the average intensity is supposed to be the same um, in all directions. But hang on a minute. According to what we have learned in the previous lectures, U naught is equal to the total radiated power divided by 4 pi. So from this equation, d beta is equal to U, and then we write down here, and then 4 pi. So this is another new formula we have learned. And we can bracket it. Yeah, we can highlight this. Yeah? Because this formula is often used. Now, how about the maximum rate? The maximum directivity. Based on the information here, we can say right that maximum is going to be 4u 4 pi u maximum divided by power radiated. So this is equation 2. And equation 2 can be rewritten. How do we do this? Yeah, let me free up this space here. We are going to continue. And we are going to retain this environment here. This equation, yeah, is going to be retained because this is the important conclusion. Without this, you will not be able to derive this formula. Now, Dmax is equal to this maximum directivity, so-called. Uh, so D max is equals to 4 pi this one. So can we rewrite this equation? We can rewrite it into this manner. U max. And what is the total power radiated? We can rewrite this. The total power radiated can be, we don't have enough space here. I think the best thing is we write down the formula here. Yeah, and then we continue. We don't have enough space. Yeah, D max. Yeah, we remember this. Okay? Now, it is equal to 4 pi, and then what is R vector? R vector is given by this, we can calculate this here, U, and then power is also equal to intensity times the area. Okay, because intensity by definition is the power per unit solar angle. Sorry, I should say the power can be calculated by the intensity times the solar angle. So in this case, we have the angle right here, okay? A different direction, the intensity will be different. And the intensity times the solar angle. Solar angle is expressed in this manner. Okay? Beta will be scanning from 0 to pi, and phi will change from 0 to 2 pi. And do not forget that the bottom expression, U max. Okay? Now, we have learned that based on what we have learned in the past, U max is actually the normalized power. This formula, right? U divided by U max is the normalized power. So why don't we just substitute this into here? So we just continue. And what we will get here is normalized power. And then, and then sine beta d beta d. And the good thing about this formula is the bottom expression can be directly substituted with the total beam area because this is the definition. This this guy here is the beam area for pi, and then the beam area is given by um, I don't know what kind of equation. Yeah, maybe this beam area. Okay, beam area. So is equal to the beam area. Okay, up to this stage, um, I think I have given you enough information. The important thing is we need to derive the expression to formula based on the radiation intensity. And if you have any questions, please leave your questions to the comments box, and I will try to answer your questions later. Um, Meanwhile, thank you very much for your attending the lectures. Bye bye.